You know, how can one resist?
Why should we?
That's another term.
Yeah, because it's one of the.
But I also.
Sorry? I do not want to. I have it. Yeah, go ahead. Okay. Yeah. No, I'm not planning on it.
Yes.
I'm probably getting tortured to go, but this is not really.
You should hold to that. I don't know, I mean, this is the one in Paris used to be.
No, that's okay. Well,
Okay. That's what I thought, but this is something different. Yeah.
The choice between the map or Florida's.
It depends on the time of year, I can make a great job.
Yes, exactly.
No, absolutely.
October's lovely.
Yeah.
I'm thinking of something. Hi. Everyone here for beer today?
Calling Tony. Is Tony in the room? Hello, Tony.
You wish.
Interesting. Anyone have beer with Tony last night? I've not seen him yet this morning. Seriously? Holy crap. I'm going to just text him first. We'll start, but I want to make sure he knows we're starting without him, and maybe we can see if he's okay. All right, I sent him a text. Hopefully hear from him. I'm going to sit over here, but that kind of doesn't let me address that because I have to run slides from this side. I like queuing these, but this laptop doesn't like me, so let's see how we do it. That worked. Hey. Oh, Tony says he's on the way, so all right, he's at least conscious enough to respond to email, so that's good. Okay, now I'm totally baffled. How do I, there we go. I got an arrow on this and PDF. Fit to page. All right. So you guys in the right place? Beer? Good. Everyone's looking up at me smiling. I love that. Look at those direct eye contact, huh? Minutes, please. Someone raise your hand. I need minutes or we can't move forward. We have to have this documented because there's always discussion after about who said what. Somebody. Wow, look at that. Eyes solid on the keyboards. Come on. Is that a response? Is it, you kind of, come on. You're good at it though.
I'm sorry, I'm not going to be as focused on.
All right, got it. I know people, we get a lot of conflicts when people leave. Someone's got to do this. Who's not presenting today? Who can sit there and do? All my usual suspects are presenters. Hey, you thinking of doing minutes? Yeah, thank you. Please, we need someone, and I trust you completely. There it is. All right. Jabber Scribe. Is someone on Jabber? Anybody on Jabber? We have no one on Jabber either. Damn. AD, what's our role if we don't have a Jabber Scribe? We got to roll forward with a Jabber Scribe. And normally he's right here doing this for me. Anyone? We got 6 people on here, so we can't not have a Jabber Scribe. Can someone hop on Jabber? Is that Tony behind you? I see a shadow. No, he's not coming in.
Yeah, Turtle says he will.
Pardon me?
Turtle says he will.
He's got him? Thank you.
How can we recall an AD? How does that work?
Just asking for his name.
Somebody else.
You have to participate in-
Oh, you said Torless. Oh, okay. Yeah, that's fine. Well, I can torture Torless with all kinds of agenda items. Thank you, Torless. Appreciate it. Anyone recognize this guy? You're supposed to be our Jabber scribe. So here's the existing agenda. There's been a lot of discussion about it. Thank you guys for participating through here. I think I missed one. We got it in there. And then we'll have some good discussion here moving forward. I want to start with working to doc status, because I've had a handful of you come to me and say, hey, this doc's ready for last call. What's the queue? What's going on? So what we chose to do with 4 or 5 documents ready for last call, I didn't want to hammer, because we're all volunteers. Our time for the IETF is voluntary, right? I don't expect people to respond immediately, but with a 2-week window, at least a yes or no lets us progress. So let's look at the status. Okay, we had cleared, bar IPA cleared in February. Still waiting for a shepherd. I've hammered the list a few times looking for shepherds, and we don't have them. So I do have someone just stepped up this morning, volunteered for this one. So I've got a shepherd assigned for that, and we'll move. Let's move down. TE ARC. 4 people responded to the thread saying, I accept this as a last call. Nobody else. We can't call that consensus. I can't, in good conscience, send that off to the IESG. All right, there's a lot of people participating here. This is a significant addition to the overall architecture of beer, adding TE, and I cannot move this forward without some good review. So at least Torless did rev it, so I guess there's some input that's taking place, but this is where we are. I'm going to start it again after this discussion he's going to present today, and then please respond, and then we can get some, and that response could be no. If you don't think this is ready for last call, if there's comments, but please participate. Otherwise, I'm not certain what we're doing here. All right, next, LS.
Let me translate. You people suck. You better step up your game, otherwise you get fired.
Tony does not speak Shep. He's tried and failed countless times. Shut the door. Shut the door. Turn off the recording devices. BGPLS. We got 8 responses. That was good. That's on the high side. But we had the author, May 31st, we had some really good comments about the document itself, which kind of sat dead. I tried to kick them a bit. July 12th, we actually had a reply to the doc. Good. So some progress is moving forward. However, I think the comments warrant a rev because there was some corrections, there was some clarifications. So I would like to see that revved. Once revved and submitted, we can go back to last call on that, get confirmation, and get a shepherd, and we'll move. MLD and PIM signaling are both just sitting in my queue. I was just kind of waiting for these others to progress before I take them to the list. But if you think there's something we can accelerate on that, we can move forward. Something missing?
Yeah, so MLD, we retracted that one, right? So we introduced a new one that Cisco, Juniper, and ourselves.
Perfect.
So
Okay.
it's just the PIM signaling, just to be clear.
Gotcha. All right. Oh, so I'm sorry, can you say that again? And name at the mic, please.
Sure. Human, Nokia. So the only one we want to do a last call on is IETF beer
Okay.
PIM signaling 05.
And the status of MLD just got revved, right?
Yeah, so the MLD, we removed that, but we are presenting a brand new way of doing it on
Perfect.
this IETF.
Okay, thank you. Okay, we have a Jabber scribe now.
This is Stigma. I want to clarify that. So I think we agreed last time that it could go to working group last call, the MLD draft. I do, however, have a question to the group this time to see whether we should make some addition or if you're good the way it is now.
Well, it'll be presented today.
Yeah.
So, Human, my apology. I confused MLD with MLDP.
Okay, yeah, it's okay. I did on the email thread too. Fair enough. Where are we? Last one here, right? It goes the other direction. All right, next doc. PMN. So Greg. Excellent. Again, sorry for the conflicts. This has been a kind of a conflicting week. I'm going to take it to the list again to just ask a request for working groups that other people are participating in so we can try to get that list cleaned up. All right. Thanks, Greg. Yeah, that's what I just do the PDF thing rather than bouncing around.
Yes, it works. Got the comments, reviewing comments from Alvaro, and we discussed it, worked on it. I worked on them. Some suggestions were very straightforward, and it was easy for me to make changes. And some questions they're coming to the working group, and actually Alvaro sent the document back to us, so we need to discuss this how to change the document and how we proceed. So some comments that were easy to address is to make RFC 8321, which is on describing alternate marking method, and experience that Telecom Italia has with using it, from information to normative references. We have the discussion about their use of terminology and packet network performance monitoring, which might be nice term, but in 8321 it's used only once. So we agreed to use marking method. The question was about one of the examples that is in the draft that says that if the head already marks the packets and some nodes, BFRs are monitoring. So the narrative goes that it says, okay, it's easy to start monitoring in other nodes. Yes, it's not that easy because there needs to be some instructions given to node to set certain probably ACLs or something to start monitoring for the markings. But the idea was that basically from the head there is nothing to do, so it's only dynamically enabling or disabling the monitoring point. That I think that it was addressed. Alvaro suggested to add operational consideration section. It's added, but it might not be up to level, because the question is outstanding from Alvaro is that can we or can the document provide more specific recommendations in terms of parameters of these coloring blocks and frequency of measuring delay. And security section, yeah, security section was really weak and just plain wrong. I apologize for that. So the question is that whether there is an integrity protection. And as far as I know, the alternate marking method does not have integrity protection. Actually, the idea and goal of alternate marking method is to have as minimum footprint as possible. As I mentioned, some of questions and comments not addressed, and they require working group consideration. Can we go to the next page, please? Oh, no. Yeah. Yeah, open questions. So the track 8321 is experimental. And experimental for the reason because Telecom Italia way of implementing it in IP, they used space of differentiated services code point field, and only in their network. So basically, it's non-standard, and IPv4 doesn't have a good way of supporting alternate marking method. Because of status of 8321, so Alvaro raised the question why this document is on the standard track, and since we don't have reports of implementation and deployment of alternate marking method other than Telecom Italia recorded in RFC, so whether it should be experimental or informational, and that's something for the working group to discuss and decide. Another question is, we do have BIER OEM requirements document, which was already a working group last called, and clearly this draft on applicability of marking method in BIER is to address some of the requirements.
Greg, quick question before it escapes my mind. For the for the marking, has all the IPR been disclosed?
Yes.
Perfect. Thanks.
So, and the question is, if we are progressing this document, why the OEM requirements is not progressed, at least in a step with it? Am I correct?
Alvaro, do you want to go one question at a time, or do you want to just go through the whole slide and come back? Or
Actually, I think that's the last slide.
well, I know this is the only slide, but what I mean is, do you just want to?
Well,
Or do you want to discuss each step, or what do you want to do?
Okay, my understanding is that I want to inform the community about this discussion, even though the discussion was on the mailing list as a summary, because I don't know if we can reach the decision here. So it will be great if we can reach decision here. My expectation, or I came to the meeting with expectation that we might start the discussion, but the final decision will be made on the list, and it's probably will have to go for another working group last call. That, I don't know.
This is Shep as chair asking my boss man over there. What we're producing are specifications, right? A requirements doc is often, I look at it as being a working document for the group. It's not always needed to go all the way to publication. It's just used through the process. So if there's something in there we need to reference directly, then maybe we need to progress it. I would prefer to address that in this doc and move it as a solution.
Right. So specifically to that comment, that's why, because the 3 points there are independent. So that's why I was asking, do you want to go question by question or what? When I was reviewing this, among other things, I go check the mailing list and other stuff, and then I found on the mailing list that requirements draft. And I thought, well, this one that is trying to solve an OEM problem doesn't even talk about the requirements draft. Doesn't even say there is a requirements draft over there, right? And then I think, if I remember correctly, it went through last call, or it's in some state like that. So my question to Greg, I think, was, what is the relationship? Now, his initial answer was, okay, we meet requirements 2 and 4, or something along those lines. But there are like 14 requirements. So, of course, the next question is, well, what about the other requirements? If the working group agreed, whether we publish the requirements document or not is irrelevant, but if the working group agreed on a set of requirements for OEM, and we only support 2.
I can answer it. I think that I tried to answer it.
So that was my question about,
Yes.
about the relationship. I don't think we necessarily need to publish the requirements. I agree. All my question is, if we already agreed on a set of requirements, maybe we should say something about why we don't address some, because maybe they don't apply, or whatever it is.
Yeah, I'll have to go back and read them all to give you a solid answer, but it would seem to me that, especially with OEM requirements, there's not going to be one tool to solve all those requirements.
Right.
This is a tool that solved a few. And maybe if the document's going to stand as a list for us to accomplish and complete, then maybe we should continue with it, reference those pieces as the tools are developed, and then we can finish our list.
Right. And the other question related to that was that, because it looked, and I have to go look again, it looked like that requirements draft may have been through working group last call. And so I wasn't sure if the intent was to publish or not. So my opinion is that if we are going to publish the requirements draft, I agree with you that we don't necessarily need to, but if we are going to publish it as an RFC, it makes sense to me that the requirements at least are published at the same time as the solution, not after, because then after it has no real value because we already solved the problem, right? No real archival value. So that's just sort of a process timing thing that we need to worry about.
So again, as chair, and Tony can kick me if he disagrees, but I've often looked at the requirements documents as something to keep open until complete. It's trouble in an OEM case where we have a tool that solves a couple of them, knowing it's not going to be one tool solves all solution. We'd like to see that thing progress, but there may be requirements that come up along the way that get exposed because we're just developing an architecture and starting to finalize this stuff. It seems a little premature to publish that one now when one tool addresses only a couple of the lists.
So again, that's why I was asking what's the relationship. And as you said, we don't necessarily need to make that requirements document an RFC. So when you say keep it open, to me, it sounds like you keep working on the draft. And sure, you can reference the draft from the RFCs as informational. And that's it, right? The draft just stays there.
So why I encourage the requirements on the OEM side initially very strongly is because we have no tradition of publishing good OEM on our technologies, okay? And this is major carrier stuff, and I think we have to shift this culture. And then having these requirements not being contested, because there's so many OEM things, right? Models, what you could do could lead to some productive work rather than go and argue once, a couple of competing OEM things have materialized. Now, whether the requirement should be published in informational, I don't think so, because you have a good template to go and beat other people over the head and says, like, that's type of OEM I want you to bake into the next technology so we can deliver the stuff solid. But, whether you see any value in that or not, and our job is to deliver and carrier grade OEM with beer or for beer or whatever, So I consider that a nice vehicle, and publishing and documenting that allows people historically to track back, right, what we're up to and which tools can do what. But we can also skip it and just hear the tools. Fine with me.
And we could, Greg, again, we could progress with like you said, informational reference to the draft, and then at some point make a decision whether we move that draft forward too, if we've concluded all those requirements with tools. Would that make sense?
Yes, and maybe not. The reason I'm saying that is that if we ended up with 5 tools or whatever that solve most of the requirements, and now we're just documenting that for posterity, I don't know if we need to. Okay. If we couldn't meet all the requirements with the 5 tools, and there's some other stuff, as Tony said, that maybe we want for the future for someone to look at in 3 years or whatever, then maybe it makes more sense to put that in an RFC. But I think that's something that we probably need to circle back as we go along. Because I agree with you in what you said, that if there are other requirements that come back, that come in, maybe it's not time now to publish that draft. And that's fine. I just don't want to publish a draft that says, here are the requirements, and the solutions that solve all these requirements were already published. Because that is what seems to not make a lot of sense. If there are still outstanding requirements, that's a different thing.
Just comment to that a bit. It seems that may be more of a semantic argument. I mean, the OEM requirements document started first. We worked from it, developing these tools. Just because the publishing process was out of order doesn't mean the process was out of order. Right? It's a perception, and as from the outside, it may look like that happened just because of date of publication, but clearly we know in the IETF documents didn't begin at publication date.
Right. I mean, it's just a waste of other resources later, because we need the operations and security and everyone else to go review the draft and the ASG and all that stuff for something that we already know was used, I guess.
I see. Right. That would be a brutal process regardless. We've already been through.
Right. And then we're going to have, 13 other ADs abstain of the document because we already published all the solutions for that. Okay. So I think that I would rather either publish the requirements at the same time as the solutions.
Okay.
Or if, as Tony said, there are requirements outstanding that are left for the future, then we can, still publish it then and call those out. and say, we've solved all these things, but then there's these other important things that we haven't solved, that we still need to solve, but we are right now.
Then the tools that get published should not reference the draft in that case?
Yeah, then we can publish this with a reference, with an informative reference saying.
Okay. What if the draft expires?
That's okay. It's informative reference.
And then if new requirements come up, we resurrect the draft.
Yeah.
Sounds good. I like that. Room? That makes sense to people in the room?
Sorry, I was standing on the line for.
I know, but I'm referring to his conversation still. So did that make sense to people in the room? Nods, hands? Okay. Do people agree that that's a reasonable process to go forward, to publish the tools, keep the draft open, we can reference it, normative?
No, informative.
Informative, excuse me.
Informational.
Thank you. Informative, and let it expire if it doesn't progress. We can resurrect it if needed.
Yep.
Anyone agree with that? Anyone disagree with that?
Yeah.
Have a different
I'm
process?
standing here on the line to say
Okay.
that I completely disagree, right? I
Good.
think it is, not helpful for furthering, work in the IETF when the stuff that ultimately people are referring to understand why the heck are these protocols doing all these crazy things are seen by the IESG as second-class citizens in the process that we're doing, right? In my case, in the Anima working group was also, you don't do architectures, you don't do requirements documents. In the end, all the stuff came up during IESG review of a lot of the documents, and all the explanations went and bloated up specifications, which is worse than what we have here, which is perfectly fine standalone documents that are run in parallel. And sometimes the explanation of why these things that these protocols are doing are needed take longer than actually coming up with the protocols themselves. And then somebody comes, oh, you're too late, right? You should have finished all these requirements in detail before these protocol bits were developed. I'm sorry, but I'm on completely the opposite side of Alvaro on this one. And sorry, Thomas Eckert, I haven't read this. I'm not, for this specific, this is just very in general, my bitching about, requirements, documents being seen as something, sorry, we already got too much to do, go away.
So let me just interject. What we're discussing now is IETF process more than the working group process. So one more, and then we got to move.
This is Akbar. Just one comment from previous experience. If you have requirements or something that's requirements like people might object to classifying that as informative because by its very nature, it's actually normative.
Yeah.
So again, maybe if the AD, supports, I think it's a good thing to what the AD proposes and what you proposed, but in similar circumstances, we've run into problems when it went to ISG and they said, well, you cannot make something that's a requirement as informative because it goes against grade.
Alvaro, talking more about IETF process. I think it depends on how you make the reference. So you can get away with both. Now, the thing is that if it's normative, then what that means is that even if you send this for publication now, we'll have to wait for the requirements to be published. And that's equivalent to what I was, the other alternative, which is let's publish everything at the same time, right? So it's equivalent. Either you send me everything at the same time or you send me everything in pieces and then everything gets published with an RFC number at the same time at the end.
Greg is chair. That being the case, then the only risk would be if new requirements come up, we have an addendum to the RFC that got published with the requirements draft, right? At that point, it's just semantics, really. The process is the same. We just call the document.
Right, and what I meant is that you can keep working with the requirements draft all you want and then send it later. And because if it's normative, the other RFC is going to wait.
Thomas Eckert, so again, for normal requirement stuff that's kind of closed and seemed to be finished for whatever is done, I don't think what I wanted to say is interesting, but I thought that Warren had this thing going on with a more agile, document option, and maybe that's something. Okay.
So tomorrow at 8:30 in the morning, there's a living documents site meeting.
Perfect. All right. See you there tomorrow morning.
Okay, so
You got more to go, Greg?
Yeah.
time out on this discussion. I don't see any action items. What, it adjourns to the list, or otherwise give us marching
last
orders?
point on this slide. Yeah, last point on this slide. Okay, the draft currently has IANA section, and I agree with Alvaro that it's odd because Only what it defines interpretation of the OEM field, which is a part of BIER MPLS header. So there are a couple questions out of this comment is, so can there be other interpretations of OEM field, or only ones that will be defined in this draft? And if interpretations of OEM field is only defined is in draft, does it mean that this draft updates the RFC 8296? So in any case, IANA consideration section is not needed, because if there could be other interpretations, then they do their interpretations. If it's the only interpretation, then we update the draft and IANA has no action. And then the question of the naming. The loss and delay versus single and double marking method. It's
Okay, Tony. So if we go the route, I'm kind of agnostic that this can have multiple interpretation. You have to specify a mechanism, how this, the semantics are being signaled. And you can say very well, it's out of band configuration, whatever, but you have to say something, right?
And that's what the draft says right now. There's no way to discover what you're doing.
Right.
You configure the two endpoints, and I interpret the bits that way. Right. And that was a question because, yes, the BIER header has 2 bits. And it says that it can be used for OEM, but it doesn't say how. The way I interpret the RFC is that it's open to the OEM method to describe how, and then you agree. But the way this draft was written was that it was basically taking ownership of those bits.
Yes.
And not leaving the room for others to use the bits in a different way.
Right.
So that's a question to the working group, right? Is that the interpretation that the bits can be used by any method, and it's just a matter of configuration or discovery or something? Or is the intent that we're going to assign those 2 bits to a specific mechanism? And if yes, then is this the mechanism you want to assign them to?
Well, there's no advantage to take ownership of those bits, right? Okay, so ladies and gentlemen, those are pretty much, watershed decisions here for the foreseeable future.
Next steps? Yeah. We're going to take this to listen to start discussing these things. So some good points came up. I mean, we should highlight those from the minutes and I'll bang those things out. Who's got the minutes again? Where'd he go? There you go. Great.
Mm-hmm. Okay.
So we have to go to last call again.
Yes.
Just because of the rev.
Yeah, which is...
So who's read the current rev of the draft? We got 4 people.
No. Actually, I think that we need to discuss it, and because actually all these open issues, they're not addressed.
Before we get there.
Yes, so basically it's a track relationship with the requirement document,
right,
and flags, and again, then relationship with the BIER header.
So let's spear this with a dedicated thread and email, highlighting those issues with the intent of getting some conclusion and a rev, and then we go.
Okay, then I'll start 3 threads and we'll go from there. Thank you.
Thank you. Sorry for the conflict. Thanks for making it happen.
I appreciate your.
All right. Jeffrey. It doesn't. You know how to full screen this? I'm in PDF mode and I get this scroller is all I get, and I do that.
Actually,
that
do you
just
have PPT mode? Because I have some
let's see, is it PPT mode? It is a PPT mode. Look at that. We can switch between them. Is that it? No, I have to sign into Microsoft to use it. Yeah,
okay, then PDF. Then.
Right. That's kind of where I've concluded all my work. I mean, the new Windows tool, Microsoft tools, I have to be online. Yeah. So I said, I'm done.
Okay.
Edit on a plane.
All right.
Now I lost it.
Let's go back.
and back again. There we are.
Okay. So this is an update to the beer tethering drafts. We have Daniel Adochi from Verizon joining us as co-author. We added some text about possible looping prevention, and then some other scenarios like one for many and many for one protection, not helping. So some quickly go through the basic idea of beer tethering. It's in the brownfield deployment situation, how do we handle incapable routers? You either get around them or you tunnel through them. In the left picture, that's where we get around them. The router X does not support beer, so even though going through X is the best path for Unicast point of view, because it does not support beer, then we'll go through BFR too, even though the cost is higher. Another way is the tunnel through the incapable routers. That's in the right picture. We tunnel through X. Next slide. So section 6.9 of beer architecture spec talks about how this tunneling is done automatically. I'll skip it. Next slide, please. So tunneling alone, it works, but may not be good enough. In this picture, imagine that, okay, so because there is no animation here, who has to imagine for a moment that BFRX does not exist here. So for BFR1, we need to tunnel 4 copies of the packet from BFIR1 to BFR3, 4, 5, 6 respectively. And if the link between BFR1 and router X does not have enough bandwidth, then you're wasting your precious bandwidth on those copies. So the solution for that is that we attach a BFRX to the router X with a local fat pipe. Then the BFR1 will tunnel the packets to the BFRX, just 1 copy, and then BFRX will tunnel individual copies to 3, 4, 5, 6 through that local fat pipe. Next slide, please. So because that's BFRX is like a stop router there, so the normal 6.9 procedure will not work. So to make it easier, we do some additional signaling. I'm going to jump to the alternative method there, where basically the BFRX signals that I'm the helper for this router X. With that, other BFRs will use the section 6.9 method to tunnel to BFRX, and BFRX will then in turn tunnel to other BFRs. Next slide, please. So we had that simple picture there. We had attached the BFRX to the incapable router, but notice that BFR 3, 4, 5, 6 in the picture, they are connected to X, they are capable of beer. Any one of those or multiple of those could all be the helper to X, as long as the connection between the helper and the helped is fat enough. So when you have that kind of situations, the signaling that I'm X's helper can carry a priority, so that the ones with the highest priority is used as helper. And you could even have multiple ones advertising the same priority, then all those could be used. Another situation is that one helper could actually help multiple non-BFRs. We'll have a slide later for that. So with OSPF's ISI signaling, the helper needs to be in the same area or level as non-BFR that it helps. That's the OSPF ISI signaling. I also have a slide on how to do tethering with BGP signaling later. Next slide, please. So you may have some concerns on possible looping situation you may get into. What if BFR1 tunnels the beer packet to BFRX, and then somehow BFRX sends packet back to BFR1, especially if you have a direct connection between BFR1 and BFRX. So there are some simpler scenarios where if you have a dedicated stop helper that does not have any other connections, then you're guaranteed not to have any loop. Or if you have a helper that has other connections, for example, in this picture, BFRX has connections to BFR 5 and 6. It's no longer a stop helper, but as long as BFRX does not have a connection back to the tunnel ingress, then it's also fine. But you may say that it's probably harder for me to guarantee my topology like that. And next slide, please. It turns out that it can also be guaranteed as long as you do an extra SPF calculation. If you let me jump to the bold and slanted text there. Basically, in this picture, BFR1, when it decides whether BFRX can be used as a helper, it just does a SPF calculation with the BFRX as the root. If it realized that if somehow BFRX would use BFR1 as next hop to reach BFR3, then BFR1 will not tunnel packet to BFRX to reach BFR3. So that extra calculation is actually no different. It's the same as the extra calculation you use to prevent looping in the LFA. So it's the same idea. In fact, you can view the tunneling of from BFR1 to BFRX as a LFA protection pass. It's just now you're always using that protection pass instead of going through the native pass. So that SPF calculation rooted as the helper is the way to guarantee that you do not get into the looping situation.
This is Greg, this independent. Just trying to follow the example. I understand what you're trying to do, but the example has me a bit baffled, and I don't know why that would be a problem here, because you're going back. I mean, why would it go back to BFR1 in the first place if the bit's not set for that, and no ingress would set its own bit coming in? So it would only work if BFR1 was the path through X back 3 and 4, that it would take that path, right?
So in this picture, imagine that the connection between BFR1 and BFRX has a cost of
yeah, it's 3. It's the same cost back to X.
Right.
But the cost of BFR1 from BFRX is now 4 through X and 3 for the BFR1. But why would it send anything to BFR1 unless a bit is set for it in this topology as well?
It's that I think, first of all, ignore the matrix there. Maybe the matrix is not right to explain the problem. Let's just imagine that BFR1 send a packet destined to BFER3 to BFRX because BFRX is the helper. And somehow BFRX does its calculation, realize that, the to reach BFER3, I actually have to go through BFR1. In that situation, then
okay, that makes sense.
But that extra calculation, that is the same thing we do for LFA purpose, will address this concern.
Thanks.
So when we first came up with tethering solution, I always kind of nervous that will I get into looping? And with this, I'm actually much relieved that this is fine. It's going to work out. So, next slide. So what if you have a situation where you have you want to use one helper? In this case, it's BFR XY in the middle to help multiple incapable routers X and Y here. That is just a special case of transit helpers. So as long as you do the extra SPF calculation and make sure that you won't get into looping, then you can use the BFR X, Y to help both X and Y here. This slide is about how you do the signaling with BGP to do the tethering. I had an animation in the PPT mode to make it easier, but now I'll try to explain. So if you look from the right side of the picture, BFR ER3456, they advertise beer prefixes along with tunnel encapsulation attributes. That attributes is set to the BFER3456 own beer prefix. That tunnel encapsulation attribute basically tells the receivers of this advertisement that when you send packets to this for this BFER for this BFER, you send it to the BFR encoded as in the tunnel encapsulation attribute. So, for example, when the BFR3 gets that announcement, BGP advertisement, and it gets a beer packet destined to BFER3, it will send the packet to BFER3. Now, BFR3456 continue to advertise those BFR prefixes to BFRX. To BFRX. Now, this time, it will change the tunnel encapsulation attribute to BFR3456 beer prefix. With that, when the routers on the left side send beer packets with some bits set for BFR-ER3456, they will just simply send the packet to the BFR3456. Now, when X gets that advertisement, it will re-advertise those to BFR-X, the helper. Now, this time, X no longer sets itself in the tunnel encapsulation attribute. Instead, X will change the tunnel encapsulation attribute to address of the BFR-X. Now, X does this does the same thing with BFR1 and so on and so forth. So when the packet from BFR-IR1 arrives at BFR1, BFR1 will send the packet to BFR-X because that's what the tunnel encapsulation attribute says. And then BFR-X will follow the tunnel encapsulation attribute and send the packet to BFR3456. I wish I could explain this better in here, but if you, I think I'll send the PPT to the email to the mailing list, and that way people can read the draft and then can follow the animation, and it's easier.
It's uploaded anyway.
Oh, the PPT.
Material, yeah.
Oh, okay, good. Go
Yeah.
there. Okay, it's just we cannot display it here.
It's
Okay.
asked me to log into Microsoft. To
Okay, good. All right.
The tools.
Okay.
Sorry.
Thanks. So, in summary, tethering a BFR helper will reduce the copies of tunneled packets over resource-scarce links, so it helps. There are two options to signal, and the preferred solution signaling is to advertise that helper advertise that I'm the helper. With that, the incapable router does not need to do anything, which is a good thing, because in most cases, if you cannot do beer, you would not want to upgrade it for whatever reason, even a software upgrade. And we have some flexible tethering options. You can have stop helpers, you can have transit helpers, you can one for many helper or many for one helper. And we know that if you do the extra calculation, you know that when to go through the helper or when not. Next slide. So we continue to see comments, and the authors also believe that the document is mature enough for working group adoption. So we want to request that.
Thanks, Jeffrey. Who's read the draft in its current form? All right. Who thinks it's ready for last call now?
Adoption.
Adoption? Oh, I'm sorry. Adoption.
Let's see what
I was just doing a last call list. Back off. Where have you been the first 10 minutes? Who thinks it's ready for adoption? All right. So it looks like those who read it are on board. We'll take it to listen. Thank you, Jeffrey.
Okay, thanks. Do you have some questions?
Sam,
I'm sorry.
Disclaimer, I didn't read the draft, so bear with me. So X, in this case, is going to keep the state of all the endpoints.
X?
Yeah, I mean, if you go to the topology.
Can you go to?
Whatever, I don't know whether you call it's more like a proxy or more like it. Can you call it proxy?
Yeah, yes, it's proxy, but the reason we don't call it proxy is that there is already another draft with the proxy. That proxy is really draft is really about it's re-advertising beer prefixes across areas or across protocols. That draft already used the proxy term, so
I see.
That's why we're not using C. Indeed, it's BFRX is the proxy for X.
Okay, so it's going to keep the information what BFR1 is supposed to keep. Is that right? Because you're tunneling to X, and X will actually going to forward the packet to different BFRs downstream.
No, BFR, the helper does not keep additional information except that I am the helper of X. That's the only additional information that BFRX keeps. That way, when BFRX does its calculation, it knows that I'm not going to use X. And then the other BFRs, they only remember that BFRX is the helper for X. Therefore, when for example, in this picture, when BFR1 does the section 6.9 procedure, instead of replacing X with the X's children that supports beer, it will simply replace X with its helper, BFRX.
I see. So you're, in other words, whatever the advertisements the control plane is going to send to the BFR IR1 will remain the same.
Right.
So it's not going to re-encapsulate or anything of that sort.
Right.
Got it. Thanks.
Yeah. Okay.
One more.
Human Nokia.
Mike or not Mike? You got a question? Go ahead, Human.
So most of the examples here, I see only one router that cannot do, that is not beer capable. And we are trying to get around that one router. So I'm just wondering, how realistic is this in like a provider network? And the second part, maybe with the same token, is let's assume that now that one router becomes a cluster of a router, like a ring. And we want to bypass that ring that is not beer capable. How will these procedures go?
So let me first answer your very first question. Imagine that you have a network where most of the routers do not support beer, and those routers are like workhorses for unicast. They can handle tremendous amount of unicast traffic, but now you want to add beers, and it's not feasible to add beer support to those routers. In that situation, in theory, you could attach a small BFR router to any one of them, and then you can just do the tunneling through that help. That's in theory. So you can just you just look at your network and you see that, okay, even though there are many beer incapable routers there, I could attach a helper for every one of them, or I could just simply pick a couple of or a few of strategic replication points, attach helper there. So that's one way to do it.
Yeah, again, I think it's a great idea. I'm just trying to understand, like, how far down the road do we think this procedure is going to be relevant? So, like, just thinking about like a third-party off-the-shelf ASIC kind of thing, which does a lot of throughput and doesn't do beer. You know, I can understand if it's top of the rack type of switch, and you want to bypass that, then maybe this comes in handy. But is this the type of scenarios that you're thinking about?
No, it's when you say top of rack, you're talking about data centers. Yeah, beer.
Yeah, exactly, like a 5G data center or something like that. All I'm trying to understand is, like, where is this going to come in handy?
Any network where you think that you want to start doing beer, and it's just for in a short term, you don't have every router that can support beer, you can do it. It's just a matter of how many helpers you want to attach.
Can I answer to your question? Is that okay?
Yeah,
So, Niels Warnke, Deutsche Telekom. To your question, how relevant this is, as a co-author also from this draft. For example, in our network, it is relevant. If you think of the brownfield approach, and you have a life cycle of about 5 to 8 years once you renew the router, we have done the calculation on our end, and we see that we have some routers in the middle of our backbone which will not be beer incapable. So the question is, what do you do? Yeah. Do you wait until you have got a complete refresh cycle of all routers which are beer capable? Then you have a very long time to cover. Or are you looking for ways around how you can do, for example, tethering, so that you enable the network to, with side machines to really gain the profit of beer in order to make it then the whole backbone beer capable?
Just a side question. In that case, like, there are two scenarios here. There's a tethering scenario, and there is a scenario that we go away from the non-beer capable. So going away from non-beer capable, that completely makes sense to me. You know, put a router that is beer capable, your unicast goes over the one that is not beer, and your multicast goes over the one that is beer capable. The one that is for tethering, which actually tunnels the beer through whatever LDP, SR, or whatever it is. So in that case, you're saying that the router, so there's no way to put a beer capable router beside it.
Put a beer capable router beside, you just can't bypass it.
Right. Just a quick comment down to for Human's question. If you want to go around, get around the incapable routers, then you still need to ensure that eventually you have a connected graph for all to reach all the BFBRs. And sometimes you may not be able to put in those additional connections. You can put a router in there, but you may not have an extra fiber or connection for that. With the tethering, as long as you have a local fed pipe between the helper and the helped, then the rest will just work out.
Wait, Sandy, then we'll after you, right?
Okay. Sandy Zhang, ZTE. My question is, I just read the newest version of this draft, and I found that there's two type of node is defined in the draft: the helper node and the helped node, right? And it reminds me the BGP feature for graceful restart, and only the node who will help other node will send the feature of helper but no one sent the helped filter for it. So I'm just wondering if we should define only one type of it, just helper, not helped.
So for the first comment, yes, there's a helper and then there's a helped. Remember when it comes to signaling, I said there are two ways to advertise the helping information. That the second one, I am the helper of X. That with that the helped router, the one who does not do beer, does not need to do anything. It's just ignorant of anything. And everything is handled by the BFRs and the BFR helpers. So does that answer your question, or?
But if the node which can't support beer, he will not send the beer prefix or other information associated with the IDP or BGP extension, right? So we know that this node can't support beer forwarding. And we can also think this node need help, right?
Oh, right. The thing is that if you look at this picture here, even though this is BGP, just forget about it, this is about BGP. So here X does not say anything, and BFR1, following the existing 6.9 procedure, if you will realize that, okay, X does not support beer, therefore for BFER 3456, I will have to tunnel to BFR 3456 correspondingly. And that will work, but it does not work well because BFR1 needs to tunnel 4 copies through X. Now with the additional advertisement from BFRX saying that I am helping X, then BFR1 will say that, okay, now instead of replacing X with BFR 3456 following the section 6.9 procedure, I will just simply replace X with BFRX with the helper. So that's the trick here.
Okay.
All right, we're really behind here. So we did the next, I guess we addressed this all the way down.
Okay.
Any other questions to address this? So in the discussion, where's the DT guy? There we go, great. On Human's questions as well. Maybe an example that shows incremental deployment as opposed to the tail end of the deployment, right? Like I've got a couple nodes I can put in and the majority of my network is not. How would this tool migrate as opposed to, because the scenario is like one left node as opposed to, a couple of beer nodes and everything else not. Would that be like a valuable, Human? Would that be valuable to the draft that we showed that incremental deployment as opposed to like the tail end?
Yeah. Okay, I can add that. It's easy.
Right. I think clearly these questions are coming up. So if it's looked at as being transitional, it would show what that path would be. All right. All right. Next. How do I get out of this? I found the button, so I'm making progress here. Oh, by the way, I just found this slide too. If you have PowerPoint documents, they need to be converted to Google Slides and just follow these simple instructions.
What was the discussion on the mailing list?
This was at my desk right here, right? So apparently I'm supposed to do this to allow you to animate for every deck. It's just to let you know this is not going to happen up here. But if you need this stuff, maybe we should all go to Google Slides instead, and then it'll be a quick move. Thanks. All right, next is signaling over beer. This is MLDP, not MLD. I did the same thing on the mailing list when I saw the request come up.
Yeah, there one letter difference between them. This is the second try for the MLD signaling over beer. The previous draft that we had, I think there were some concerns about the way that the signaling was done, so we retrieved it, and here's a new way of doing it. the main problem is the same, right? So we are trying to a segment of the network. We are trying to go to beer, brand new hardware that can support beer, and we got all these access or legacy multicast parts of the network that they want to be communicating over this new beer, let's call it the core, and we want to make this happen. Excuse me. With minimum disruption or software upgrade on these legacy multicast networks. So next slide, please. So now the way that we're going to do this is via RFC 7060. We're going to try to connect the two MLDP islands together over the beer via signaling TLDP through the beer core. So literally, you're going to be seeing the TLDP packets on the beer core. They're not being tunneled or anything like that through the beer. You're going to see the signaling going from the IBBR to the EBBR, and they're going to signal the MLDP fix through the core of the beer core. One thing you got to keep in mind is that usually MLDP, as everybody knows, is in a DU mode. With the TLDP, it's going to be downstream on demand, meaning that IBBR, when it gets a FEC from the receiver, will actually ask from the label from the upstream router, and the upstream router, which is the Egress BBR beer edge router, will assign that label to the downstream router. Next slide, please. So from procedure point of view, again, on the IBBR is very simple. When MLDP FEC arrives on the IBBR, we find a TLDP session to the other beer edge router. The way that we find that egress beer edge router is via procedures described in RFC 7060 or procedures that are already in the draft IETF PIM signaling. So those procedures on the IBBR will actually identify the egress beer router. Now, the egress beer router, again, it's the last router that supports beer before the root node on the point to multipoint LSP. Next slide, please. So on the EBBR, basically the procedure is when these FECs arrive from the IBBR, the EBBR needs to track all these FECs. The reason that it needs to track the FECs is for the same FECs, it needs to be build a beer header, basically the same story as PIM signaling. And also the EBBR, as it was mentioned before, it assigns the upstream label. So there are multiple ways of doing that, but we feel that that assignment needs to be unique throughout the entire beer domain. And that's why the draft MVPN, EVPN aggregation label, which uses like unique upstream label assignment, it will come in handy in these procedures also. So next slide, please. So when it comes from data path perspective, when the packet comes back from the root with the MPLS label, it arrives on the EBBR. The EBBR will do a swap with the label that it has assigned for all the downstream labels. With the same token, it's going to look at all the BFERs that are interested in this FEC. Based on that information, it's going to push the beer header on top of it. We are thinking that the beer header protocol should be an MPLS, so the BFER can identify that beer packet as an MPLS payload and actually remove the beer header, look at the MPLS label underneath, do a swap with the label that is relevant on the leaf domain, if you will, and then forward the packet through the second MPLS island, if you will, access island. And that's how the data path works. Next slide, please. Yeah, so the next step for this is, we definitely want comments on this draft, any questions, comments, and we are hoping to ask for working group adaptation.
Who's read the draft? Who thinks this should be adopted as a working group item? Solid support from those who read. Let's take it to the list. Thank you very much. We are really behind, so I'm going to start pushing stuff through. Sorry, but that was a good discussion, especially when operators communicate. Thank you. I may have erred on that, but I don't regret it yet. Give me a 30 minutes, I'll regret it all. All right, next is HTTP. Dirk.
Yes.
All right.
Hi. Should be a quick one. Okay, so this was an update to the multicast overlay for adaptive streaming services. Since the last IETF 104, we have a use case that we expanded. It comes to the next one. We have the draft shows the reference architecture and the realization of the multicast overlay in over IPMC, but also over BIER as a comparison, if you will, and the pros and cons for both are described in the draft. And for the realization over BIER, we provide the operational details for elements like the PCE service handler, et cetera, that are introduced in the reference architecture. Can we go to the next one, please? As a recap, the yellow ones are the application elements that are described in the draft, and the red elements are the elements that are introduced by the reference architecture for the use case, meaning the service handler as well as the PCE. And the multicast overlays then formed by the IR and the ERs of the BIER layer, and the service handler is performing the additional operations for the actual streaming service of the use cases. Go to the next one, please. The details that we've changed compared to the previous version is that we added a second category. So we focused initially on the HTTP-based streaming use case, where we added a description of Dash in there. I guess that's the realization in one of the examples. But we also added another use case for HTTP-based software updates that's been added in the new version to just have two different categories of HTTP-based services. We also added and enhanced the security considerations to address a comment from the previous IETF on the HTTPS-based exchanges. So the certificate handling is being included in that section. These are really the changes since the last time. So next steps is, well, first of all, I'd like to have comments and really, people, reading the draft, providing comments back. And from our perspective, we are finished with the details, and so would be asking for last call for this draft specifically.
Just looking, when was 01 published? That was just after Progman, right?
Yes, yeah. It was a quick update. It was a very quick update.
All right. Who's read the draft in its current form? You're an author. All right. Who thinks it's ready for last call? Yeah, I got soft response. A couple hands went down. We can let's take it to list open thread. I mean, again, last call is often just a stick in the nest to get you guys to read it and respond, right? So I'm going to put it in the queue with these I've got going, but we need to respond to these so we can progress this.
Mm-hmm. Very good. Good. Thanks.
Thank you very much. Okay, next being Torless. Have you seen this guy? He has no Tor, none.
Better than no socks.
I'm here for you, man.
There's a Jabber discussion focusing on my socks. You missed it.
On your socks?
Yeah, there are no show socks. Everybody will fascinate.
Oh, mine are no show. That's these back.
Next slide.
Look us.
I need a run.
Serious stuff.
Oh, I'm sorry. Are we having a meeting?
Okay,
Totally
so
has that effect on me, I'm sorry.
right, so this is in working group last call. You heard the working group chair. Please read it. Please provide feedback. We really want to get it out to IESG, right? Just a few more voices. And so we thought that when we read it ourselves, that some of the past comments were this is obviously somewhat difficult technology. So we added text to better, I think, get started in reading it in the beginning. So next slide. So improve the abstract, right? So basically even we introduced BRT. Obviously everybody knows what traffic engineering is. No kind of per packet, stateless, strict and loose path engineered replication and forwarding, right? Using beer packets, call that BRTE. The basic examples I'm going to show, and then basically we added how this topology thing that the basic examples show comes into picture in the architecture. And then also for people coming from this world of segment routing, trying to find some way on how to upsell BRTE to them in their terminology. Okay, so this is the basic example, right? The first one on this slide is showing hop by hop native, so to speak. These are all layer 2 adjacencies forwarded. You see the full BIFTs of all the routers, and then the text 1 page or so walks through the forwarding of an individual packet, how each bloody bits does its work at each hop. So next slide. Same thing, overlay. So basically we've removed 2 of these routers from beer. They're not beer capable. So now you've got forward routed adjacencies between the 4 remaining ones, comparison also how the bits react. And basically those are the 2 type of, extreme BRTE topologies we can think of, a native one and overlay. You can have any combination. That's what the examples in this new introduction part say. So, and that basically means in the architecture paper, it's really the BRTE controller host, right? So the controller discovers the network topology, and out of that, it creates whatever it thinks is the best BRTE topology, overlay, native, combination, and the rest is obviously was already there. But this particular piece of explanation, hopefully, few more people reading it with this new text, understanding it, saying great, right? So that's what we're trying to do.
Please.
Last slide. Right, so then, there was the word segment routing missing in the in the title here on the slide. Sorry. So yeah, so basically the BPs in the sense of segment routing can really be seen as equivalent of forwarding segments, except that you can't take a bit position, and think, oh, it's a global thing. I can send from it from anywhere, because the whole trick of how to steer things through it is that only, the adjacent nodes have this bit and replicate to it, right? So basically, maybe in this terminology, we call these BRTE bits adjacency scope forwarding segments, right? So, I mean, it's just more food for thought on how you see it. Also saying that SR can naturally be combined with BRTE and help to optimize it, right? Whenever one is steer without replication, SR is fine. The whole point of BRTE, of course, is to steer and replicate, right? And then the last one, which I think more people from just the beer side may have an opinion about, is that, you can also see that beer itself, kind of just destination sit with efficient replication, right? Instead of having a long list of egress sits in a packet and replicating on that, well, every sit is, compressed to 1 bit. So that was kind of, this can all be removed if people don't like to be compared with SR, right? We're just hoping it's helpful to bring people to beer. And that's it. The end.
Wow, even conclusion. That's kind of cute. We'll take that to listen to the response. We took this to a last call before. We had 2 people said it was ready for last call, but we've since cleaned some things up from response. We can start the timer again, make sure the minutes note that. I'm going to take a vote who thinks it's ready, because we thought we were before. What we need are people who are ready to read. So please participate. All right, next, after Torless is Stig. This is the 3-letter M acronym and not the 4-letter M acronym.
MLD without the P.
Ouch.
Yeah. All right. Just go to the next slide. I guess there's only 1 slide really. So I thought we were done with this document, but then I realized that there's one thing I want to discuss with the working group. Currently, we are saying that the source address of the MLD or IGMP messages is the beer prefix, and we use that to figure out the beer ID of the sender. And subdomain, we can't really figure out. We just say it has to be configured in some way, or you can use multiple instances as it's discussed in the draft, and you could say for a certain destination address, we assume a certain subdomain. Anyway, in PIM, we decided that we wanted to use a join attribute to explicitly specify the beefer ID and subdomain and so on of the join sender instead of relying on this. And the question is, should we do something like that for IGMP MLD overlay? The issue is that a typical implementation, or at least some implementations, when you parse the IGMP or MLD packet, you don't have access to the beer header. That could tell you who sent which beefer sent the join message or IGMP MLD report. So one option is to say, we'll just go with what we have. It works. It just makes some assumptions on the source address and configuration and stuff. Or we could potentially delay this draft further and do some work on extending the IGMP MLD messages to include this information. I would say normally it's a non-starter to modify IGMP or MLD, but these messages are only sent or received by beer routers, so it's not like we need modifications in any existing implementations. Also, maybe a bit of a background. In the IGMP version 3, MLD version 2 RFCs, it is explained how you can have additional data in a message, and how existing implementation should just ignore any such additional data. But we could possibly update those and do something special for beer if that's what you want to do.
Human Nokia, just thinking out loud, isn't this the same comments that were made for PIM signaling?
It's the same, yeah.
So wouldn't the same hardware would have the same issue?
Yeah. So that means either, yeah, so if you have that issue, it means that either we need to add this information, or we need to just enforce and say, use the beer prefix as the source and decode that from the source address.
Yeah, I agree, and I think that's understood. All I'm trying to say is that, so for PIM, we made an assumption as a working group that, using the beer information from the beer header could be hard for certain hardware.
Yeah. So I think that's.
So I would imagine that
yeah,
could be the case too.
Yeah, that's so assuming that is not possible, or it is very hard, then we only have two options. Either we just say, use the beer prefix, get the beer ID from that, just sort of getting subdomain by configuration, or the other option is extending IGMP MLD messages themselves. And yeah, I'm just curious what people think about this. I'm kind of agnostic myself. It could be nice to include that extra info. On the other hand, it works the way it is defined now, and it's nice to be done with this. But I think it's good to discuss it or think about it before we publish the draft.
So, all right, Jeffrey's coming to the mic. All right, good.
So, Human again, in my opinion, it's fine the way it is. Any hardware that supports beer is some next generation hardware that can read into the header. So,
okay.
Since we did that additional signaling for both PIM and actually MVPN as well, we might also do this for IGMP.
And I guess one question, if you want to do this for IGMP MLD, is it worth publishing what we have now and say this works, and then do some kind of update or new draft later with that extension, or should we rather wait? The problem in what I just said though is that implementations may have to deal with two different ways of doing things, so maybe it's better to wait.
Yeah, I guess. Other than that, so we don't have RFC for a little longer. There is no other bad impact, right?
Yeah.
So.
At least, I mean, even if it's not an RFC, people can try to implement what we have now, even if we delay the publication. So, maybe we should check on the list, but if people agree, I'm happy with what Jeffrey said. If people agree with that, then it means he won't do a last call yet.
Okay.
We may actually need to go back to the PIM working group and talk a bit about what is the best way of doing this kind of extension for IGMP MLD.
So I heard conflicting suggestion there. One was progressed, one was taken back to PIM. So you're saying this conversation should conclude with PIM before we go to last call?
Let's discuss this on the beer mailing list for a little while, I think.
All right.
But if the decision is to extend IGMP MLD, then I think we'll have to discuss it in PIM as well.
Good. Noted? All right, thanks.
Okay, thanks.
Next it's the Sandy Show. You got 3 in a row. You ready?
Good afternoon. I'm Sunny Zhang from ZTE. This presentation is for beer in IPv6. We have co-author Tony Ice and many people. So we know that Horman and Mike. Yes, please let me read it. Let's see the advantage of beer. We know that beer can achieve multicast by hop forwarding. And APC 8296 defines 2 beer encapsulation with MPLS and non-MPLS. And from it, we know that a new Ethernet type for beer is defined. If we want to use beer forwarding in IPv6 situation, we can use the native Ethernet packet to forward it. But we know in many networks, the recognition of the new Ethernet type for beer cannot be supported. So we defined a general and the simplest way to achieve the beer forwarding in IPv6 situation. And so we just introduced a new protocol, and you can call it a new header in IPv6 frame. And it can achieve the fast forwarding path and the slow software forwarding path, multicast forwarding. And in order to receive the IPv6 encapsulation beer packet, a router must advertise the beer IPv6 encapsulation transportation sub-TLV. It's a very simple sub-TLV for the beer information TLV, or defining OSPF or ECS or BGP. If a router advertises many encapsulation ways, such as IPv6 and Ethernet or some other, the router must accept all the encapsulation that it advertised. Next, please. Because the extension to IPv6 header is very simple, so let's see the other fields in the IPv6 header. For directly connected neighbor, we know that the destination address should be the neighbor's link local address. And the source address should be the router's link local address. But as we all know, we can define the local policy on the router that we can keep the source address unchanged or the other policy. So we can make make many changes for it. And of course, the IPv6 TL must be set to 1. And let's see for non-directly connected neighbor. The destination address should be the beer prefix of the neighbor, and the source address should be this router's BFR prefix. And of course, the TTL must be large enough to get the packet to the neighbor. And the flow ID in the IPv6 packet should be copied from the entropy field in the beer encapsulation. Next, please. The beer header is very simple because it's aligned with the format defined in RFC 8296 for a non-MPLS version. And the LSR Ethernet extensions from Sensio and the beer prefix redistribute draft can be used for IPv6 encapsulation, transportation, advertisement associated with a prefix across IGP areas or protocol boundaries. Thanks, Jeffrey, very much for his help for editory. Thank you. So, any comments?
Mr. Blue Shoes.
Sorry, Turtle Secret, haven't gotten around reading it, but is this meant to support, the way it sounded, partial deployment of some hops use IPv6, some use Ethernet encapsulation? Seems to be possible, right?
You can use Ethernet in the network also, but you know that some chips will not support the recognition of the new Ethernet type, right? So we can use this IPv6 extension to achieve the beer forwarding. So beer packet will be the payload of the IPv6 header, and you can do hop by hop forwarding to achieve multicast.
Well, I'm saying I haven't read the draft, so I haven't seen if there's anything about partial deployment capabilities, given how you have. It doesn't say anything about, the slides don't say anything about that. It's just kind of implied by the fact that you can have a remote neighbor and you're announcing it in the IGP. Is it meant to be auto-discovering?
Yeah,
Yes.
it does. Yes.
Yes, out covering. Yeah.
So the idea is not only the encapsulation, but also the system-wide thing that in the IGP you're kind of trying to figure out what's your next neighbor toward the destination that's beer capable. Okay.
Yes.
Because it didn't say this. It's just
Tony
sold
P.
just as an
Carlos, so I
encapsulation.
think I think we spelled it out in the draft. The primary intended use is towards HomeNet, which means you have V6 chips which you cannot modify, but you don't need a high throughput, right? You could build a fast path for it. Go look behind the IPv6 header and process what is inside on L4. But if you don't have that, then you have pure IPv6, you pop it up somewhere to a slow processor, and you can process the stuff without changing any of the V6 chips or any MPLS or Ethernet support.
Okay, that was a great answer, just not for the question I asked. So the
Well, so
the
it's not
idea-
meant for partial deployments. That's your answer.
No, but basically it's meant for partial support networks. The network can partially support beer, and it will automatically build beer across the nodes that can support it. Yes? No?
Define partial support.
Well, because if some nodes don't do beer, it seems as if you could get over them by having this non-directly connected neighbor stuff that you were mentioning.
Oh, yes, but that's just unintended consequence, which is the strongest force in the universe. So it was intended to be purely hop by hop.
Okay.
But of course, you can go multiple hops, so all of a sudden you don't have to build tunnels, right? You can just use V6 to jump over
Exactly,
stuff. Yeah, but that's unintended consequences.
There's
So-
no
It's an IP over IP. Yes.
So as a native kind of multicast person, you don't like it, but an operator could see it as a benefit.
That's precisely how I saw it.
Okay, right.
Yeah.
If the draft would say that, that's fine. That's fine. So the only other small comment is, I'm not sure about the cost of copying the entropy field into the flow ID, and I'm not quite sure if both of them have exactly the same ECMP meaning. So maybe either sell it stronger or degrade it to a may, because forwarding plane, there is a cost of copying these things.
Yeah, entropy is just a tag. How you process
It depends on your server.
That's an
Yeah.
infrastructure. That just tells you. So when you get to those conditions, you make those decisions.
Right there, but there's a lot of explanation in beer, and basically, I don't think.
You have at least to say that if you find an entropy on the beer, you better have the same entropy on V6, whatever it is, because otherwise you start to misorder. Okay.
Okay.
One more
Stig, so I think the draft says, just on the slide here, that you are using link local address and TTL01. So it seems clear that you can't bypass a non-beer router.
No, it says also you can go.
Okay, but if you allow a global address and larger TTL then you could, of course, yeah.
Okay. All right. So where are we with this doc? It's adopted, isn't it?
Yes, may I
It's
ask
adopted. Let me see,
for
I can't
working
look
group for
at both
adoption?
these here. I'll go to my data tracker and clear this up. All right. Boom, third rev. It is Zhang Beer. So its current name is not an adopted draft. Right, it's not a working group document yet. It's not yet a working group document. It's just, it's not adopted as a draft for the working group yet.
Yes.
Right.
May I ask for?
Yeah, I'm still checking status before I did that. I'm just confirming with you on my names I got here. So who's read the draft in its current form? Okay. Who thinks this should be adopted by the working group as a working group item? I've got, yeah, everyone who read and then some more. All right, let's take that to the list and we'll go from there.
Thank
But
you.
you're not moving. You gotta stay right there. You're on the hook for a few more here. Thanks, Sandy.
Thank you.
Source protection.
Yes, source protection. Okay, this presentation is for beer source protection. We have co-author Greg and Chen. Let's see the background of this draft. We know that the multicast source always connects two or more, always to ingress routers to avoid single node failure. That's easy to understand, right? If this domain is beer domain, we know that the ingress router, we call it BFIRS, will advertise the source information to all the BFEIS. The egress router will select the router which he think is the priorest router as the upstream multicast hop and signals to the selected BFIR. So in this picture, we know that the BFER2 will receive the advertisement from BFIR1 and BFIR2. And from the local policy, BFER2, maybe it will choose BFIR1 as the UMH. So BFER2 will signal to the BFIR1 to get the multicast flow. When the selected BFIR fails, in this picture, we suppose that the BFIR1 failed. The BFER2 will choose the BFIR2 as the UMH and signal to it. From it, we know that the sooner of the BFER detects the failure of the UMH, the quicker the multicast flow recovers. So in order to accelerate the detection time, we have some solution about it. Next, please. The first solution, let's see the beer ping. So it's the same example. BFER2 can send the periodical ping packet to the selected UMH. In this picture, it's BFIR1. So BFIR1 should reply to BFER2, the ping packet. So BFER2 will monitor the status of BFIR1. And also, the BFER2 can monitor the path status from BFIR1 to BFER2. If BFER2 can't receive the reply from the BFIR1 for a period of time, the BFER2 will treat the BFIR1 as a failure node, and it will signal to the BFIR2 to receive the multicast flow. And in order to achieve this goal, the SMP ping or the ping defined in beer ping draft can be used here. But there's a problem in this solution. If the path from the BFER to the selected UMH is different from the path from the UMH to the BFER, in this example, we can know that if the path from BFER2 to BFIR1 is different from the path from BFIR1 to BFIR2, the pin packet may result to incorrect result. Because if the path from BFIR2 to BFIR1 is broken, but the path from BFIR1 to BFIR2 is good, but the pin packet will not be received by BFIR1.
Comment on Jabber. Doesn't the ping establish bidirectional reachability?
We can use traditional SMP ping. Right? Sorry.
No.
Repeat.
So do we use beer ping or we do traditional ICMP?
Right, these two can also be used. Yes. You can use the traditional ping because the ping is from the BFER to the BFIR. So the two functions can always be used here. It depends on your choice. So if the path is different, maybe the pin packet will be lost in some ways, and so BFER2 will make the unnecessary switch over.
Yeah, I think I might be wrong, but this is Stig. I think what you're saying is if you have asymmetric routing, so the path to the first hop or to the BFIR is different from the return path.
Yes, yes.
Then the request might be lost on the way to the
Yes,
egress.
yes. Next, please. Let's see the second solution, the BFD. It's defined in the BFD draft. So we know that in this solution, the ingress router will send the periodical P2MP BFD control packet to all the BFERs, which select itself as the UMH. So the egress routers, in this example, we know that we suppose that the BFER1 and BFER2 and BFR3 all choose the BFR1 as the UMH. So BFR1 will send the periodical P2MP BFD packet to all these three routers. So if somebody, in this picture, we suppose that BFER1 cannot receive the packet from BFER1. The reason may be the BFER1 has failed. The other reason may be the path from BFER1 to BFER2 is broken. So BFER1 can choose the BFER2 as the UMH and the signal to here. And so in this function, we can use the BRPing packet defined in BRPing draft to bootstrap the P2MP BFD session. So this is an easy way. And there's the path from the ingress router to the egress router is the same with the multicast flow. So there is no the problem that will caused by the BRPing, just we mentioned in last slides. Yes.
This is Greg. Question. Is there a reason why you're not running BFD between both candidate from both candidate BFIRs down to the BFERs? It sounds like you just have the BFD running on one case, and when the detection a failure is detected, you have to then not only re-elect, but then reestablish a VFD relationship and begin that process. It seems it would be more expedient to have that running between both, and then you'll know if you get a double failure, you'll know if one comes back live, right? There's an active relationship between both candidates.
I think you mean that if all the BFIR should send the BFD packets to.
Right.
This is a question because for different multicast flow, different BFIR will be chosen for it, right?
Sure. So,
yes.
So then they should all know.
Yes.
Right.
Yes. So we think that if the choose BFIR is sending the packet to it's necessary for the choose BFIR to sending the packet to all the BFIR, right? And maybe the BFIR2, the backup, we can call it backup right? Backup can send the peer read packet also.
It has what? The backup has?
No. I just mean that because in this feature, we know that the BFL1 is the primary sending packet, but maybe BFIR2 can respond for some other people for the multicast forwarding, right? So BFIR1 can send the periodical BFD packet to the BFER1 to BFER3, and the BFIR2 can send also the BFD packet to the other BFERs, which selected it is.
Right, I think
UMH.
you jump to an application of it, but I'm thinking more just from a protocol design operational decision. The BFERs decide which BFIR. Okay, so if they're deciding, they need to know who's all there. They need to know the liveness of all of them that are there, right? So it's almost like you're letting them decide, and then you're making them tell the BFIRs what they're going to do to detect the liveness. It seems to me, I'm just saying, if I knew that all were there, and I'm independently making decisions on which one I'm going to use, I'd like to have all the information all the time. And then I could decide, what's my primary backup, whatever that algorithm is in the spec or some decision they make. Right? And then you can know if I have a double failure. If a BFD died on one and I try to reestablish another one, I am assuming it's there. It may be gone as well. The failure may be somewhere else, right? Or between the two. So it's noise in terms of messaging. And the state machine already has to be ready. It seems to be a more efficient process if we just let them communicate all the time.
So there's many ways to know the failure of the ingress router.
Sure,
right?
That detecting my neighbors to begin a process is not really expedient. Once I have my neighbors and I want to elect between them, that's much quicker. I need to be on top of that stuff. So is there an example within application the uses of BFD where I'm not just doing point-to-point liveness, but I'm doing a redundancy comparison like this? If we take an existing mechanism using BFD that's not beer related, that looks like this, we'll just, then we have some precedence. Jeffrey's got to answer? Okay.
So imagine the overlay here you use is BGP and VPN. Then what you have presented so far is already covered by the fast failover.
Yes, and VPN fast failover draft.
Okay.
Yeah.
Right. And another question here is that with BIER, supposedly the unicast FR mechanism will be used, and then you can quickly switch over to the backup path. So most likely your traffic will recover very quickly. And now when you use this BFD or PIM to decide to switch to the backup BFIR, I wonder if that switchover would take longer time for your BIER traffic to recover with the original BFIR.
The egress router can send the signaling to the backup ingress router for backup purpose, right? But it's not included in this draft. I think it's many ways to achieve it, right? Because the signaling will take time.
Right.
Yeah.
Right. So first of all, detect BFD for the BFD to detect that you have a problem, that takes time, and then you send a signal into the backup BFIR. That takes some more time. So I wonder by the time all this detection and switchover request happens, the original the traffic from the original BFIR may already have recovered on the backup path. I'm just curious if that could be the case.
You're just thinking a solution. Right.
Stig here. Yeah, so I agree with that comment. So if there's a link failure, you might be able to route around it, and you may not need to choose which ingress router is forwarding. What you maybe could do is do some kind of forwarder election, though, and do BFD between BFIR 1 and 2. And if one of them goes down, then the other one takes over as a forwarder. If you imagine that you actually join to both the BFIRs, but only one of them will send you data.
Yes, in PIM you can join the two BFIRs and receive the multicast flow, but you just forward one flow from the BFIR1 and discard the other flow.
Yeah, just quickly also, if you're using MLD overlay, you are sending your MLD reports to all the beavers.
Yes.
So either of them can decide on their own which one should forward.
Okay, one more question. We got to move. Go ahead.
Niels, just as a extension to what Jeffrey and Stig just said, what are you trying to cover? When you're trying to cover a node failure, I'm not sure if this is the right mechanism. If you're trying to cover the link failure, then the underlay is probably quicker to detect it than you can do with the BFD in the overlay.
Because the BFD can detect the node failure, can also detect the link failure, right? Because the path from the ingress router to the egress router, it will, if the route is broken, the BFD packet will be discarded. So you can use the BFD way to find both the node failure and link
Understood.
failure.
My comment is more on the line. I think this is already detected in the underlay before you get the response from BFD.
Can I address that? That one's been beaten up, but you had a specific question initially about node failure. All your comment was, I don't think this is the right mechanism. What would be the right mechanism for node failure then?
More on the line what Stig has mentioned before, so that you join to two ingress routers and balance it via the joins there.
But then they have to communicate between them to know who's actually is live.
Then the BFER has to know which nodes exist, and the underlay does detect if there's a link failure and it doesn't reach that one anymore.
Underlay, we're talking node failures on ingress. That's the underlay is just going to give you topology information, right? And it'll route packets accordingly. I've joined them both. They need to know which one is going to send packets on behalf of those joins.
Yes, but
all right. So that communication is where they
detect. Sure, but if I can't reach the node anymore, and this is probably quicker detected in the
who are you? You said I can't reach the node.
If the BFER doesn't get any route anymore to the BFIR.
Routes? I mean, the failure could be not just, I have a route to it just fine. It's not moving packets anymore because the link behind it's failed, and that's not going to be in my IGP. I'll never know.
Exactly.
Right? It's not, it can no longer act as a BFIR.
Yes.
That's different than it's down. Right? So route to it is not going to be detection.
Okay, that's a different use case than that I thought about.
Well, it's still redundant as ingress routers. They can fail in numerous ways. It'd be nice to have a mechanism that address them all. And instead of a bunch of pieces taken up.
Fine, as I said, this was a different use case than I thought about.
Okay.
I think this picture may cause some confusion about it. It's not one hop from the egress router to the egress router. It's a multi-hop from the ingress router to egress router.
So I misread every IETF draft.
Oh, wow. Oh, I forgot to dot in the picture, right?
Or just a cloud picture right there.
Yes.
This is great discussion. I think we need to really consider all of the failure scenarios. It'd be kind of interesting to break those down and see what we have in terms of solutions, what problems they're addressing, and maybe if there's some open problems. But so who's read the draft currently? All right. And I don't believe it's adopted, right? It is still an independent draft.
No, not that was called.
Okay. And you think this is kind of the work we'd like to adopt in the working group? Do I see any hands? I see a few hands. Okay. All right. Because honestly, I think it's worth taking on this just Greg independent, just to keep these conversations going so that we come to a conclusion. Whether it goes all the way to RFC or not is irrelevant in our process. We have to solve problems, and whatever those solutions fall out, this is helping us get there. I think we should do it.
Thank you.
Oh, I have a question. Yes, young lady.
Hi, Aaliyah Atlas. I haven't read this. I haven't.
Whoa, yes.
right, I haven't read this particular draft, but on the case of sort of trying to detect node failures and so on, the MLDP fast reroute RFC talks about figuring out whether it's a link or a node failure based on where traffic streams are coming in. And if you haven't looked at that, you might find it interesting.
Yes.
Great input. Thank you.
Thank you.
All right. You have one more, I think, don't you?
Yes. A last one. BFD, yeah.
BFD?
Yeah.
Okay. I was going to, you just talked BFD, but that was showing how to use it. All right. Makes more sense now.
Still me. This presentation is for BFD. Because the author can't attend this meeting because of the visa problem. So I present this draft for her. The update of this version is the description about BFD session bootstrapping, and the active tail part has been updated. And we know that the multi-point BFD and active tail draft has been published is FC proposed standard, FC 8562 and 8563. And also the other modification is about the BFD sub-TLV or sub-TLV carried in the OSPF and the ECE's advertisement. It's aligned with the BR information advertisement.
Just kind of pushing you through this fast because we have to get another item up. So go ahead.
Okay. The BFD is based on FC 8562. So it uses the demand mode to build the BFD session.
Okay,
so,
can I just jump in on the time? This is great, but this is not showing how it works. This is just, you've done your homework. This is great. So let's go what our next steps are here. So the idea, I think with BFD and how it's all standards based, which is excellent. I had the one comment about that use case. If there's an existing use case where BFD is used like that, and we can kind of use as a model, be beneficial. Are there other use cases in this draft besides the one you just presented beforehand? Or in mine, at least?
The previous presentation is for this. Yeah. Yes, it's a usage of the BFD, right?
The only one?
Not the only one. I think it can be used in the other function. Yeah.
Or who's read this draft? No readings. Wow, I'm trying to think, it was a long time ago. Yeah. All right. So I think it's willing to throw it to the list, get some feedback on it again. I think the work from this is right now is tied to the previous draft, which we're going to take to the list anyway. So I think it makes sense to have this part of the conversation. But we'll take it to the list and see where we go.
Okay. Thank you.
Thank you. Sorry, Sandy, for pushing you a bit, but we're almost out of time, and we've got at least one more here. We got Mike McBride.
Hey.
Hey, look at his face is up there. Hi, Mike.
Best looking guy in the room.
Have you been watching us all this time?
Yep, and Tony talks.
All right, go for it.
Okay, so at this point, 3-minute review. There may not be any time for discussion, but this draft has moved from a problem statement to a requirements draft per last IETF's discussion. We've, per the decision of the working group, moved the requirements section up, making that the main focus of the draft. We added Rajiv as a co-author. It's now a working group document, and we've put out a new rev, mainly developing the requirements section. Next slide. Hopefully you already know what the draft purpose is, so next slide. So these are the requirements, and we've added some more commentary to some of these requirements. We have a few additional requirements that we intend to put into the document between now and next month. And please look at these requirements. If you go to the next slide, you'll see some of the new requirements that we intend to put into the document. My suggestion request based upon our last discussion is that we probably shouldn't do any working group adoption of the existing solutions until this requirements draft is more mature. And I think we can commit to, by next IETF, having a requirements draft that we as a working group are fairly comfortable with. To get to that point, I think that each of the solutions documents leaders contribute to this requirements document. If you don't, we'll just keep giving our best on what those requirements are and where they get, and where the solution may best fit the requirements. So that leads us to that last slide, is just looking at the different solutions. We need to provide the pros and cons per our discussion last IETF. Else we will. We need to be as impartial as possible. We probably need to, which we don't do right now, explicitly state at the beginning whether this is an encapsulation method, if this is an encoding method. We probably need to agree on what exactly native IPv6 means to us, and because everybody and all the solutions, we all talk about native IPv6. I think it may mean a little bit something different to each of us. We don't have time to discuss it now, but we can take these things to the list. But that's our request, and that's the update.
So, Mike, thanks for much for doing this remote. I'm sorry that got crushed on time. I read through most of this again this morning, and you hit on the point that I wanted to make, and I just want to beat this dead horse a couple more times here. If there's any reason to modify the beer header, there needs to be some justification in doing so. We have a beer encoding already established. Encapsulation is what we're really targeting here. There's encapsulation use cases to do it. But when we munge the two, as you said, encapsulation and encoding, there has to be a reason why we're doing that. Encaps to get over something, but the encode's already established and it's cut in stone. We can deconstruct it, but we need to know why, right? Because there's hardware being built to pipeline this stuff through. And if there's another step to be ordered in front of it to take pieces out of an existing header and put it back into a beer structure for the hardware, and consider transitional, that's like transitional hardware is a really hard sell.
Yep.
Right?
Yeah, agreed. That will all be specified in this draft.
Okay. But, and again, I just want to read it one more point. If your solution's in this document, please step up. I mean, that's the justification comes through. You can come out and say, hey, this is what we need. Existing tools don't get us there. We need something else. Then we've got a reason to go forward with this work. So if your use case is on there and you think this is important work, you need to make your case.
Thank you.
Thank you, Mike. Any other questions? Belushi's.
Came back. Mike, thanks for the presentation. It was excellent. And thanks for keeping his auteurs.
Would you like to deliver them? You want a pen too, Torres? Sure. Here, Torres.
Hermes is on the way. Torres, you're so special.